Special code problem for the student. Note, the poster is Japanese, but because the code problem is in English, I have added an English text and narration. Of course, comments from Japanese speakers are also welcome. I ordered this book from the US around 1990 to study code breaking, and I was only able to solve about half of the problem at the end of the book. Table of contents. First, about Friedman's code-breaking work. Second, about code problem for the student. Third, the result of my attempting the problem. Please forgive my poor English. About Friedman's work. William Frederick Friedman was a famous cryptologist in the U.S. Army. He served with the Expeditionary Force during World War I, and codebreaked the German Army's field codebook. He wrote Solving German Codes in 1919. In 1977, Aegean Park Press published his paper, adding the problem at the end. About the solving code problem. Problem: the enemy is known to be using unenciphered code system. Text is in English. Code groups are 5-digit groups. In order to read the text of the messages, the student must reconstruct the codebook by analysis. Note 2 Student, solution of a code often begins by finding those code groups representing letters and numbers. In the present case, the names Smith and Davidson likely have been spelled using code groups to represent either syllables or the letters themselves. Words might be searched for, such as general, for, to, stop, period, etc. Now, let's go through the 6 code messages in order, pausing if necessary. The result of my attempting the problem. So I'll explain my progress step by step. If anyone notices my mistakes or new hints, please let me know in the comments section. Code breaking, also known as reconstruction of codebook, is not a lightning bolt that reaches the goal, but rather a slow and steady snowball that grows. Step 1. Creating an extract of messages. Here is an example of extract from the reference book. Extract the codes that precede or follow the 3-letter code K, M, E of the center column, and arrange them in chronological order in rows. An asterisk marks the beginning or end of a message. So I created an extract too. This can be done conveniently using a spreadsheet. I listed 4 codes that precede or follow the extract. Finally, sort by the extract column. From here, we can find patterns within message or between messages. Code 00101 appears a total of 10 times, and is most likely to appear immediately after 11719. Step 2. Check the frequency of code occurrences. The graph below shows the frequency of code appearances. The top 10 codes are also shown. The most common is code 45504 with 42 times. There are also many codes that only appear once. Looking at them numerically, the lowest is 00101 and the highest is 53664. Step 3. Diagnosis, one part or two part. Now that we have a clue about the unenciphered code system, how to determine whether it is a one-part or two-part system? This diagnosis is the most important step in cryptanalysis. Looking at 00101. It would seem to be letter A, if it is a one-part. Furthermore, the letter A is necessary to spell Davidson, so it wouldn't be unusual for it to be used 10 times. On the other hand, assuming there were two pat, the possibility that 00101 equals A is low. Step 4. Find the code about Davidson. Let's focus on the proper nouns, Davidson, that are likely to appear in the messages. These words are likely to be written as single letters or syllables, and tend to be easy to spot based on their distinctive patterns. It will probably contain the hypothesized 00101 equals A. The string is 3 characters longer than Smith, so it will be easier to identify. It will have an A, sandwiched between 2 Ds. So I look for 6 groups that contain 00101 in the second position, and where the first and fifth positions are the same. It has the following characteristics. First, it appears only once in each message. Appears once in the recipient's address or the outgoing signature. Second, it can appear either at the beginning or end of a sentence. It is the standard location for addresses and signatures. Third, as shown below, it is the alphabetical order of one-part codebook. However, while number 1, 2, 5 satisfy Davidson's pattern, 3, 4, 6 show a different pattern from the 6th position. So what do 43858 and 45504 mean? 45504 appears most frequently, 42 times, and is evenly scattered, including at the end of the sentence. When we observe whether this might be stop, we find that first, they does not appear at the beginning of the sentence. Second, they do not connect to each other. Third, they are separated by at least 5 words. Fourth, it also connects immediately after our hypothesized Davidson. Fifth, if 40209 equals S and 50932 equals V, then 45504 equals stop is in alphabetical order. The 43858 between 40209 equals S and 45504 equals stop is Sun. This confirms that the diagnosis is correct. Step 5. Find the code about Smith. Now let's search for Smith. The 5 codes that match the pattern where the first letter is S and the third letter is I are as follows. We can safely assume that 27521 equals M, 46896 equals T, 20795 equals H. Smith appears at near the beginning or end of the sentence. Step 6. Find the code about general. Find the general before Davidson and Smith. 19739 appears 11 times and is always connected before the name. There is no doubt that 19379 equals general. Step 7. What are the characteristics of the codebook? Let's consider the structure of the codebook. First, it is a one-part codebook. Second, the presence of "son" suggests that it was not compiled for military use, but may have been adapted from an English dictionary. Third, the leftmost digit of code is limited to 0 through 5, with the remaining 4 digits consisting of almost all of the numbers from 0 through 9. Fourth, since 00101 equals A, the first 3 digits are the page number, suggesting the dictionary of just over 536 pages. Step 8. Correlation with my English dictionary. Since it is impractical to find the exact English dictionary used by the test giver in 1979, I used my dictionary, Penguin's Pocket English Dictionary, 4th ed. The book has 991 pages, and 68,000 words. I extracted the identified code and checked which page the original word was on in the Penguin's dictionary. In the graph below, the x-axis is the numerical value of the code, and the y-axis is the corresponding page number in the Penguin dictionary. Because there is a correlation, we can predict the approximate page number. Step 9. Examine the beginning of the message. There is a high possibility that the serial number and category of the correspondence will be included here. Let's look at the 28715. They are at the beginning of the message. First, 28715 goes back to around page 527 of Penguin, perhaps a word that starts with "me." Of course, we will take into account the error of a few pages. Second, the 9 codes that immediately follow 28715 are almost all different, since numerals are often used immediately after "message." So we specify 28715 equals "message." Step 10. Identify number words. Focus on the codes that follow "message" and appear to be numbers. However, 48332 and 18324 are numerals. They also appear between stop and general point. 18324 equals 4, 48332 equals 2 are undoubtedly correct. The high frequency of 15 and 7 occurrences, respectively, makes sense, and is consistent with the correlation graph mentioned above. Let's try applying the numerals. Estimated head letter from correlation graph. The second character has a large error. It is estimated that 31142 equals number. The numbers should be consistent with the timeline sent by both sides. 17718 equals 5, 18567 equals 4, 31,705 equals 1, 42,953 equals 6, 42,958 equals 16. 48,001 equals 3. Step 11. Examining the end of the sentence. At the end of the message, notice the common code group immediately preceding General Smith and General Davidson. By the Penguin Dictionary, this corresponds to a word beginning with SI. Could it be sign ED? Here we notice an important feature of codebooks adapted from English dictionaries. The past tense of verbs does not exist with the exception. Therefore, it is necessary to use the present tense plus E plus D. So we identify 42707 equals sign, 14756 equals E. My current achievements. Now, it became difficult for me to move forward. I could make some bold assumptions, but they would be purely fictional. Unless I can imagine the situation of an enemy that is far away, it's fiction. For now, let's apply the codes we've discovered and look at each message. Please pause if necessary. Sum my thoughts. First, if this were a real operation, I'd have a significant advantage. Additional messages would arrive and further analysis would be possible. Information from friendly scouts and interrogations of prisoners would be provided. Proper nouns likely to be spelled out, such as place names, would be provided. An ignorant code clerk might perform irregular operations. Friedman's paper cites examples of German use of poetry and proverbs in radio testing or dummy message. Second, regarding the timestamp of message number 6. The other messages were sent at convenient round times, but number 6 was sent at 5:01, which is strange. Why couldn't they have waited until 5:10? It was probably an urgent message. Third, some grammatical restrictions. Plural forms of nouns do not exist, with the exception. Therefore, the singular form plus s must be used. Comparative and superlative forms of adjectives do not exist, with the exception. Therefore, the infinitive form plus e plus r, or e plus s plus t must be used. Fourth, regarding questions and answers. Is there a question mark? Using a question mark makes it easier to find the corresponding 5W1H questions. Fifth, conjunction. There's a sentence with an unusually long. Is there any conjunction? Sixth, look for standardized statements or routine reports. If there are standardized statements, such as reports of casualties and missing persons, I think that could be a breakthrough. Seventh, Over-the-shoulder cryptanalysis. Cryptanalysis isn't a solo endeavor. Reconstruction of codebook is best done in groups. If someone is stuck on her worksheet, a colleague walking by behind them might provide some inspiration. Finally, again, if you notice any mistakes or new hints, please let me know in the comments section. Thank you for watching. I am interested in Japanese cipher machines and post what I find out on YouTube and Wikipedia in Japanese.